Fine, right? So whenever I'm giving an input to my program, fine, right? So for example, I may have written a simple that is that is a simple interface program, right, where my program will ask the user for the input. Okay, right? For example, it may be adding two numbers or anything, right? If it asks me enter the values for two numbers, right? What I will do, I will type the two numbers. Okay, right? So typing the two numbers is measure. Okay, that is the information that I am returning to the user program from my input device. Okay, first terminology is measure. Okay, right? So what is this measure tells? Measure tells information that I am returning. That means the information that I am giving to the user program. Okay, what is the information that I'm giving to the user program? If my input device is a keyboard, right, it is one or more characters that I'm giving as the information to the user program from the keyboard. If my input device is mouse, obviously what my mouse can give an input, right? We saw locator. Okay, right, it can give the location where I'm pointing that mouse as the input to my program, right? So if my input device is mouse, then this position or location comes into picture. Okay, right, as a measure. If my input device is a keyboard, then the information that I am giving, right, will be considered as a information that I have given. Okay, right? So now next, once I give once I type any input to the user program, right, does it directly take it? Fine, right? So whenever I give any input, right, it will go and it will first store in the buffer. Okay, right, as soon as I type anything from the input device, or as soon as I give any input, right, with the input device, it directly doesn't go to the user program. It will be stored in the buffer. Okay, right? Then fine, what makes it go to the input program? That is the trigger. Okay, what is trigger? Trigger is a manner in which the device user can signal the computer that input is available. Okay, it is a manner in which a user can signal the computer that input is available. How do we do usually? Whenever we give the input to the program, right? How do we make the program that yes, I have given the input is ready? It is by pressing enter. Correct, Allah? Correct, right? So as soon as I give the input, fine. What I will do? I will after giving the complete input, what I am supposed to give, right? So I will press enter. That is the trigger. Okay, right? So giving an input consists of two terminologies, or consist of consist of two components. One is measure. Measure means the information that the that is being given to the program from the user, right? And trigger is nothing but, right, it is a manner in which the user can signal the computer that input is available, right? Example for trigger is, if my input device is a keyboard, after giving the input, right, how do I make my that is program or computer to tell that yes, input is ready? By pressing enter, right? After giving the input, if you press enter, right, so that input will go through the program, it will process it, and it will give the output. That means enter is the trigger here. Okay, if my measure is position of a locator, that means if my input is mouse, right, so how do I give the input? For example, if you want to give the input if you want to give the input by click as a button or something, right, what you will do, you will move the mouse to that position. Okay, right, for example, right, here only, right, you can see the screen, right? For example, here if I want to see the number of who are all the participants, right, what I can do, right, I will go to this participant. This is locator, right, where this position of the locator has been passed as an input, right? Now if I want to see who are all this, right, what is my trigger? My trigger is a click, right? As soon as I click, it shows who are all the participants are there. Correct, right? So triggers are of two types. One is enter key, or another one is button on the locator, right? So that button, if you press that button, right, so it will take the input. Fine. So coming to the input modes, right, what are all the things that constitute my input modes, right? The things that constitute my input modes basically are two things. One is measure, okay, right? So one is measure, right? Another one is trigger. Okay, based on these two things, measure and trigger, right, I can give different types of input modes. Okay, right? So based on this measure and trigger, right, they have discriminated or they have differentiated in giving the input in three different modes or in three different ways, right? First mode is request mode. Okay, right? So in examination they'll directly ask, right, explain request mode. Okay, right? So and coming to the second one, right, second one is sample mode, third one is event mode. Fine, right? So they will directly ask this for 8 marks, right? Or they will ask, right, explain different types of input modes. First type of input mode is request mode. Okay, request mode here, the measure means the information. Okay, right? The information is not returned to the program until the device is triggered. Okay, right? That means the measure is not returned to the program. That is, the information is not returned to the program until the device is triggered. Okay, right? So example for this, right? See here, this is the block diagram which says, right? Now here I have a program. This program will request for measure. It requests for measure in the sense, right? My program is requesting for the information. That is, my program is requesting for the input. Fine, right? So okay, my program will request for the input. Fine, right? So next what I will do, I will give the input. Okay, right? As soon as I give the input, right, it doesn't take, right? My program doesn't take the input. Fine, that means the information is not returned to the program until the device is triggered. Okay, right? So the best example is, right, what usual traditional programs that we write. That is the request mode of input that we are using. Okay, right? We use printf scanf. Okay, right? So using printf scanf, that is the request mode of input. Okay, right? Where what happens, right? My program will request for the input. That is, you will say printf, enter two numbers. Fine. That is, my program is requesting for the information or for the input. That is what we call it as measure, right? When it requests for the input, what we will do? Yes, we will give the input. That means we will type the input. Okay, right? Once input is typed, right, as soon as the input is typed, right, it doesn't directly go. Correct, right? So it doesn't directly go to the program. So next what we will do? We will do? Next we will trigger that process, right? As soon as I get the request, printf enter the two numbers, I will type the two numbers. After typing the two numbers, what I will do? I will trigger it. I will trigger it means, what is the trigger? It is enter key. Okay. After giving the two numbers, then I will press the enter key. Okay. I will press the enter key. As soon as I press the enter key, then what happens, right? So that measure what I have given, right? Measure means the information what I have given, that goes to the program. Okay, this is request mode of giving the input, right? Till today, right, what traditional traditional inputting that we were doing, right, using printf and scanf, right, that traditional method is called as this request mode of giving the input. Fine, right? Now what is the other method of giving the inputs? Right, one method is, it will ask printf, right, enter the two numbers, right, you will give the input. What are the other methods by which we can give the input to the program? Okay, that is the second method, sample mode. Okay, right? In sample mode type of giving the inputs, fine, right? In sample mode of giving type of giving the input is immediate. Input is immediate. That means that is information is returned as soon as the function is called, right? That means sample mode of giving the input to describes, right, tells the function method of giving the input to the program. What we will be doing in the function method, right? Using functions to give the input, right? So what we will do, fine, right? So we will already input will be ready. Okay, right? Only thing that remains to do is, right, calling that function. As soon as I call that function, right, so the input comes to my program. Correct, right? So using function method to give the input, fine, right? So if I write a function for giving the input, right, that means, right, that what is that, parameters already consist of input. As soon as the function is called, right, it gives the input. That means, right, so as soon as my program is there, right, so my program will request for the input, right? As soon as my program requests for the input, right, there is no concept of trigger, right? That means if my input is present in a, if I'm giving the input in the form of function parameters, fine, right? As soon as I request for the input, right, so as soon as that function is called, right, there is no need of trigger, there is no need of enter button or pressing the mouse, nothing is required, right? As soon as that function call is called, okay, right, so that function will be executed and it will return the information to the program. Okay, this is the second method of giving the input to the program. Okay, right? So the first method was request mode, which is the conventional printf scanf method, right? So coming to the second method is giving the input through the function. Okay, where I don't need any trigger. If just the function is called, that is enough. Fine, right? So program calls the function, right? As soon as the function call is called, right, that particular function gets executed and the input or the information will move to the program. Fine. So now what two things that we discussed, right, request mode and sample mode, right, these two methods of giving the input is program controlled, not user controlled. Okay, right? So please hear it carefully what I'm telling. Fine, right? So these two methods what we discussed, request mode and sample mode, right? These two methods are program controlled, not user controlled, right? That means, right, so here also my program is asking the input and I am giving the input. Okay, nowhere uh, user is controlling the input. That means, right, I cannot choose my own method of giving the input and I will give the input. Program will ask for some method of input and I will give the input, right? Coming to the second method also, sample method, here also program will ask for the input, I will give the input, right? That means these are program controlled, not user controlled. Okay, fine, right? So now coming to the third method, my third method of giving the input to the program is event method, event mode. Okay, request mode, sample mode, event mode. Fine. So here measure or information is placed on the event queue. Okay, right? So what this event method tells is, right, so whenever we give the measure or whenever program asks for the, yes, see here, right, whenever the program asks for my information, okay, right, so I will give the information and I will trigger the process, and that is I will give the input and I will press the enter key. Fine, right? So when I press the enter key, right, so what may happen is, right, it may happen is in such that, right, it may go through, it may go to the event mode. Event mode in the sense, right, it may go to the queue, right? Sometimes you may have observed it. Okay, right? If you are if you have opened multiple windows, and if you are trying to work, right? For example, in one of the window you may be playing something, okay, right? In playing some hard stuff games, right, like NFS or something, right? And you may be opening another window. In that window you may be browsing, you may be watching the video, right? And if you open another window, and if you want to type something, for example, you may open your mail, right? And if you want to sorry, if you want to open your mail, right, you will give your mail ID. As soon as you type your, you will type your mail ID and you will press enter. That means you are giving the measure, and also you are giving the trigger. Okay, your trigger also triggering the process. As soon as you do that, right, you cannot find that, right, as soon as you go on typing and press the enter button, right, you cannot see that information on the screen. Okay, right? After some time that will appear. This you have observed, right? If you are working with only single environment, or with, if you are only working with a single job, right, that will not happen. You say your computer is fast. Okay, on the same lines, if you are working with multiple windows, complex process, if you are going on, right, what happens, right? As soon as you type something and if you press enter, it takes some time to reflect on the screen. Okay, right? That particular method is called as event mode, right? That means there may be some event which is going on. Okay, right? So whatever event that you have given, right, that means whatever information that you have given, right, so it may want to wait, it should wait in the event queue. And whenever it its time comes in the event queue, then then your CPU will process, and it will show you, it will show on the screen. That is what they tell about event mode, where your information may be placed on event queue. There may be multiple events that may be running. Okay, right? So what happens if there is no event running, right? And if you are the your event is a single event that is running, then if there is no event in the queue, then whatever your event that you have given, right, it will directly enter the process. It will directly enter the processing part, and it will process. If there is any other events that have been already scheduled and that have been already running, then your event will be placed in event queue. Okay, right? So once uh, right, so once all those events have been completed, then your event will execute. That is the giving the third mode of giving the input, right? So first mode, it is the request mode. Second mode, sample mode, right? Third method is event method or event mode. Fine. So first method, request method, it is simple. It is your printf scanf. So coming to the second method, it is giving the input through the functions, right? You don't require any trigger. Just as soon as the function is called, right, it will input will go to the program. Third one is event mode, where if some event is happening, your input should wait until that event completes. Once it completes, then your input will be processed. Okay, right? So these are some of the input things that we were supposed to discuss. Okay, right? These were the some input stuff that we were supposed to discuss. Okay, right? So now next thing is we shall discuss something about output. Okay, right? So input, we discussed many things, right? What are the different types of input devices, this, that, right? So physical input devices, logical input devices, right? What are the different modes of giving the input, what different ways of giving the input, right? So these are all the things that we discussed about giving the input, right? So now slightly we shall discuss about outputs. Okay, right? Output means, right, it is display. Okay, right? Output means, right, I am concentrating on display. Fine, right? So now whenever I talk about displaying, right, so I'm talking about image displaying. Okay, right? I'm not talking about any ASCII characters or data display. Okay, right, this is computer graphics subject, right? So I'm narrowing down my discussion, right, to for outputting images or animations. Okay, right. So now whenever we need to display any image, right, what I will write, I will write the code. Correct, huh? Right? So code means, right, if I want to display any rectangle, right, I will write the primitive for that, right? I will open the window glut, what is that window, uh, glut open window, then I will give the window name glut, size of the window glut, position of the window, everything I will give it. Fine, right? So now what coming to the previous, coming to some age old days where the computer era started. Okay, right, we were having the cpu, right? Cpu means central processing unit, that is my processor, sorry, that is my processor, which was processing all the tasks, all the types of tasks. My processor was the only thing that was processing. Okay, right? So even if you give processing of data, right, my processor was processing. Even if you give the processing of image, my processor was processing. Even if you give the processing of any graphs or any type of information, my processor was the only thing that was processing. Okay, I didn't had any specialized hardware, right, for processing each and individual type of data. Okay, that means, right, so ordinary data, numbers or letters, ASCII values, right, processing those type of information, I didn't have a different types of processor. Processing these images and graphical type of and animation type of inputs, right, I didn't had any separate processors. It was a single processor, right? So what was happening was, right, so it was yes, please mute your microphone. Right, so now what was happening was, as there was only processor that was that is single cpu was there, main central processing unit was in charge of controlling the display. Okay, right. So what was happening, right, each and every individual statements you are giving to your cpu, and it was processing that. That means, right, first display mode you will give, right, next you will give a window size, next you will give window position, next you will give the name of the window, then you will call the function primitive, right? So in that it will, you will give gl begin, gl end, in between you will give vertex, right? Everything was processed independently by the processor, right? And it was finally displaying an image for me, right? So it was taking, obviously it was taking more number of cycles, right? And if I want to next, if I want to render the same image, that means, right, if I want to display the same image again, right, again my cpu need to process each and every individual statements, that is window size, window position, window name, right? And my primitive, calling that primitive, going to that primitive again, setting the parameters for that primitive, and again displaying that image, right? So if I was doing the repeated job again and again, right, then also in olden days what was the disadvantage was, right, so it was supposed to process each and every individual line segments, right, each and every time, and it was supposed to render. Okay, right, it was as simple as this, right? If you give, right, 100 times to what is that to find the area of a square, right, can I write that equation, length area is equal to length into breadth 100 times in my program? It is useless, right? It consumes more space, right? It consumes more cycles, right, for my cpu. So what you do instead of that, right, if I want to do the same thing again and again, right, what you will do, what concept you will use in programming? You will use the concept of functions. You will write the function and you will keep it, right? Whenever each and every time when you want the same function to be executed, right, you won't write that function again and again to execute that, right? So you will write that function and keep it, right? It will go there, right? The control will go there, it will execute, it will come back, control will go there, execute and come back. Fine, right? So that concept they started using in images also, for displaying the images. Okay, right? And a special type of processor inside my cpu, right, they started dedicating for displaying, because displaying image means it takes lot of prerequisite things setting. Okay, right, setting the window, setting the size of the window, setting the position of the window, right, and setting the background color, everything, lot of prerequisite things it was requiring. So what they did was, right, they started giving a separate part in the processor for this displaying this image, displaying this graphics, right, and they call that as display processor. Okay, in the processor only a part was dedicated for this displaying the image, right. It is as simple as this, right. So in good old days, 20-30 years, right, we had only one single channel, that was DD National. Okay, in the DD National only, fine, right, I was getting cinemas, I was getting serials, I was getting comics, right, I was getting news, right, I was getting kids serials, everything, right. Now today, as and when the time progressed, what happened, right. So lot of channels came for each and every different each and every type of events, correct, huh? Right. For now today, for news only, we have lot of channels. For animations and stories for children, we have separate channels, right. For films, we have separate channels. This was the this was the updation or modification going on, right. On the same lines, right, for this, for my processor also, right, they try to modify, where they dedicated some part of the processor for only image processing, right, some part of the processor for data processing, right, like this. And the part which they dedicated for displaying the images, they called as display processors. Okay, right. So what was the use of this display processor, right? Whenever I talk about processor, right, if they dedicate some part of processor for me, right, obviously some memory will also be there dedicated for me, fine, right. So when they solved this issue, right, by giving display processors, right, that means some part of the processors they allocated for displaying the images, fine, right. So now what we did was, right, we used the concept of this, right, it was display memory was there, right. So now what we did, right, user programs, right, that means the programs that we write in OpenGL or anything, right, all those programs were compiled, okay, into a set of graphics instruction. That means, right, if I want to display a rectangle, right, complete the code of that rectangle, right, I compiled it, okay, right, and I kept that in the display processor, these instructions, right. So user programs compiled a set of graphics instructions that we need free very much frequently, right. For example, consider I need rectangle primitive very frequently. So what I did, right, I compiled that rectangle primitive, okay, and I kept that, or I sent that to display processor, where display processor has display memory and it's stored in it. Okay, right? So now this what is this user programs which were compiled into set of graphics instruction, and we kept that in the display processor, right. What we call in usual programming, right, if a set of statements we will keep it separately, right, we call that set of statements as functions, correct, right. On the same lines here, right, the user programs which were compiled, right, into a set of graphics instruction and which was kept in the display processor's memory, that was called as display list. Okay, right. Display list is nothing but it is very much similar to functions. Okay, right, where in the display list we will be compiling a set of instructions that I need frequently, right, to render a image, and I will keep that in the display processor. Display list means it's a set of instructions that is compiled which is required for rendering the image, and I will keep that in display, and I will keep that in display processor, right. So what is the use of that now, right? So now there will be a host means there will be some user, right. So who for the first time he will write it, he will write the program, right. That program will be converted to display list. That means, right, if we for example, he may write a program for drawing the rectangle, right. That program, right, will be compiled and it will be called as display one of display list, right, and that will be placed in memory. Okay, right. So once it is placed in the memory of display processor, right, okay, and he will display that. right? So next time if I require the same rectangle to be displayed, or if next time if I want that rectangle to be displayed, right, again I will not call the client to again write the program and to process it completely and to display it, right? Already the compiled code of this of rectangle is present in display processor in the form of display list, right? So next time when I want rectangle to be displayed, right, what I will do, I will directly take that from the display processor and I will display that, right? So these are called as display lists. Okay, right? Display lists are a set of compiled programs that are kept in the display processors, right? And whenever I need that, right, so I don't ask for the client to again write all the code completely, and I will not ask my processor to compile all those codes again. The compiled code will be present in the display processor. I will use that compiled code and I will display it back. This host part will not be there. Okay, right? That is what a display processor and display list means. Okay, right? So this is what the discussion about display processors. Okay, right? So they will be asking you uh, 1 minute, right? They will be asking you to write a note on display processors. Okay, this is input mode what we discussed, right? So here next we have client and server. The client and server is simple, you can go through that, right? So I will not discuss that, fine. So next, coming to this, it is display lists. Okay, whatever today I discussed, right? In early graphics architecture, computer were slow and expensive because computer sends the information, right? It is sent to the display at a rate enough to avoid the flicker on the display, right? So the solution to the problem was display processor, right? In display processor, the instructions to generate the image would be assembled once in the host and sent to the display processor, where they will be stored in display processor's own memory as display list or display file, right? The display processor will execute repetitively the program in display list, right, at a rate sufficient to avoid flicker independently of the host. That means it will not call the host again and again to display that. Okay, right? So because once the host will write that code, once it will be compiled by the display processor, and the compiled code which is called as display list will be present in the display processor. Whenever we want that again and again, we will just use the display list that is present in the display processor and we will execute it. It is as similar as your functions. Okay, right? So the next part of display list, right, we will check it out in the next class. Okay, right? So they will ask this, write a short note on display lists. Okay, fine. So this is where we will stop it for today. Okay, right? And we will continue the next things in the next class.